Distance-time graphs. Another way to look at motion is to make a graph plotting the distance traveled against time elapsed. This represents a powerful analytical tool that we will be applying to some labs in this unit. By convention, elapsed time is plotted on the x-axis while graphing motion. The other variable, in this case, traveled distance, is plotted on the y-axis. In this example, a lab cart moves on a horizontal tabletop. The traveled distance and time are measured by motion sensors. First, we'll make a table from our observations. This table shows 9 measurements. The two variables are distance traveled and elapsed time. We create a scatter plot by plotting the points. Each data row of the table equates to 1 point on the graph. Points are not connected in a scatter plot. This is how a scatter plot differs from a line graph. A line of best fit, or trend line, can help us predict outcomes using the data that you already have. It is drawn on a scatter plot that best fits the data points. It also smooths out measurement errors. There are quantitative approaches to drawing a line of best fit, but a simpler approach will get a good approximation. Place a ruler or straightedge on the plot and move it until the edge lines up with the points. Usually, about half the points are above the edge and half are below. Then draw the line along that edge. The line does not need to pass through any data points to be correct. It often won't pass through any data points. Now we can complete the graph. The line of best fit helps correlate the data, making it possible to make predictions about times and distances that were not included in the data. For any given elapsed time, the distance traveled in that time can be predicted from the line of best fit. The line replaces the data points in describing the motion. So once you have the line, you're now going to only use the line when predicting other values. Using the line of best fit, we can predict that at 9 seconds, the cart would have traveled 17.6 meters, as seen by the green dashed lines. This prediction is made even though no data were collected at 9 seconds. This is an example of extrapolation, predicting values outside a range of data points. Interpolation, which is predicting values inside a range of data points, would be to predict that the traveled distance would be 7 meters at 3.5 seconds, so inside the data here. Slope is defined as the amount by which the y value changes with respect to a change in the x value. If you have 2 points and you want to find the slope of the line between those points, this point is x1, comma, y1. This point, let's say, is x2, comma, y2. We can find the slope using this equation, y2 minus y1 over x2 minus x1, which is the change in y over the change in x. Since the y-axis is the vertical axis and the x-axis is the horizontal axis, the slope is sometimes referred to as rise over run. This is a shorthand way of saying delta y over delta x. It's often useful to find the slope of a line in order to analyze the correlation between variables. Slope shows the rate of change of the variable on the y-axis with respect to the variable on the x-axis. Sometimes the slope of the line will identify a derived quantity. For instance, suppose we make a distance versus time graph, distance on the y-axis and time on the x-axis. Let's examine the meaning of its slope. This graph shows distance versus time for an object. The slope of the line shows rise over run. Rise is distance. Run is time. What is distance over time? Speed. Speed is the slope of the best fit line on a distance versus time graph. An object traveling at a higher speed will have a greater slope on a distance versus time graph. Higher speed would indicate more distance over less time, so your line might look like that, this way. Likewise, a smaller slope would represent an object with a lower speed, so less distance over more time. An object at rest would have 0 slope. It would be a horizontal line. So for example, if you're at a location of 15 and you're not moving at all, you will just stay at that same distance.